Good morning. Good morning, everybody. This is Engineer Suraj Singh speaking from Bharat, India on this day, May 26, 2021, Wednesday. Thanks for your attention. And title of this talk is Civil Field Engineering COVID-19 Impact on Engineering Designs, Construction, Methods, Contracts, Organizations, Communication, Coordination, Quality, AnnexSL, and why be behind quality of concrete standard materials top number 365. I'm lucky that at least I could get today morning time this video move, because yesterday and day before yesterday I could not get it. It's great. Anyway, let me see how much successful we are. This is certificate of chartered engineer, and this is certificate of fellow FI, you can say, fellow of institution of engineers. I usually put these certificates for you so that you should know identity of a person, and also that certificates are important from, you can say, competency viewpoint. But these certificates carry some meaning. These carry some meaning that person has efficiency in some field, and that efficiency must be exhibited in life. If suppose somebody is chartered engineer, somebody is professional engineer, and like that somebody is something, it conveys a meaning. It conveys a meaning to people. That person has been testified, his competency is valid. If we use this person must deliver something which is required of a person. That is what this certificate conveys, or whatever certificate people have: degree certificate, diploma certificate, master certificate, doctor certificate, or some other professional certificate in whatever profession. These certificates, you can say, publicly declare. I'm not saying these are address, these are publicly declaration, Every certificate is public declaration, and people get confidence that this person is qualified enough and we can use this person. The point still remains why I always tell you that, I always remind you, and it's my duty to remind you, being citizen of this country as well as being a part of the world, that we have to have certain level of standing in every field. We have certain responsibility. Responsibility means not simple responsibility, but responsibility based on competency, consistency. If I do something, it should be consistent. It should be consistent enough that what I know, I involve that knowledge, or I make efforts, I do efforts to do that item with that knowledge. Whatever work I do, that should be based on quality, that is expected to be inserted or inculcated into that work which I do, or people expect. Whatever goods we buy, or I buy, you pay for that. Whatever service you get, you pay for that. Payment cannot be done free. Somebody provides service, this means that person has certain obligations to deliver, responsibility to deliver. There are ethics also. Whatever we consider in exchange of that money, we should get. And if I do not get that service, I feel very much disappointed and upset that person charged me and did not do service. That person charged me and did not deliver me this product of expected level of expected consistency and competency, or you can say quality. Every product is consisted of something. Every product consists of something. Every service consists of something, and that something is product and production activity. If your product does not have quality criteria, it does not have sufficient information, it doesn't give you that level of service, then certainly you will change your service provider, or you won't buy other material from that manufacturer. That's what we do. But if this happens in general, that you are not free, you don't have an alternative. If you buy an alternative, if you go to alternative, you get same type of problem equivalently. Men say, why, how to do that? And quality does not exist everywhere, anywhere doesn't exist. It means you are kind of, you can say, kind of a slave. Even after paying demanded sum, you are not getting that product or service. And it is very common, what I can say by my experience, it's very common. What you expect you won't get. Duplicity exists in market, bad quality exists in market, trust doesn't exist. But on every product, on every title of company, you shall find seals, logos of quality. You go to any product, you buy any product, you will find on package itself this ISO 9000 certified. Well, I'm very much surprised to see such seals on all products, though products don't have quality. In fact, and it's not only here. It's not only for this country, it happens in many countries. I have tried products from various countries. When I worked abroad, I see got same impression everywhere. This means uniformly speaking, all over the world, it happens. Quality is required everywhere. Without quality, nothing can be done. That is only in speaking, only in theory, virtually, practically. This is very rare. We say that it is a must. Yes, I can say it is a must. But if it is not a must, what shall I do? What solution I have? What alternative I have? That's main point. So quality required everywhere. It's very easy to say, and that's what I'm saying. But does it function? That is my point. If it doesn't function, what's the purpose of that? I'm not going to explain again and again same thing. I'm only saying I have to question, and manufacturer has to answer. My product that I bought must answer. Service that I bought must answer. And that answer is not in writing, because in writing it's already on service contract or on your package of product. It should be in performance of service. It should be in use of product, that I get that one which I paid for, and that's what is required. Because no quality is free. It's unlimited. No, it's not unlimited. It is limited. Limited to definition which we agreed for. If this product manufacturer says, I will give you this much, that it should give that much, I agree. I don't demand more than that. If it is less than that, certainly I have a right to point out. I have a right to raise objection for. What shall I do if I don't get? I have to condemn that project, that's all. If I condemn that product, don't go for that again. And if every customer does that, maybe manufacturer changes its attitude, changes its involvement, and that's what is required. And it's applicable for, such action is applicable for both product purchase as well as service purchase. Service is equally important because our life is now dependent on services. Services we get, I think there is no element left where we don't get service. It may be through AMC or through direct purchase under warranty or whatever. Without service our life doesn't move. Just like product, if you don't have product you cannot consume product. It's like that. If we have product which has to move, which has to travel for in our life for a couple of years, we buy any expensive product like fridge, like TV, or you can say whatever else, RMO, I'm saying RO, washing machine. I'm talking of daily use products. You can say services like internet use, like telephone use, and many more, where direct service depends on product manufacturing. Means these are such products where you buy, you use, and that also involves service from manufacturer. Means such products which have to be in your home and which should serve. If, for example, we buy a car, we buy it, we use it, and service is also required. Means these products are type of continuous service requirement. Other products are the, for example, you buy table, you buy chair, it may not require that much service. But generally you can say in dynamic world of society, they is required. You know everything, you know what I mean to say. The question is, we are living in systems. We are not living in isolation. If there is no system, we cannot live. And we formulated these systems ourselves. Nobody formulated for us. We defined ourselves, and that is what systems demand. That I am designer of my system. I have to, you can say, scrutinize myself. I have to approve it myself, for myself, and for then it's for myself. But that myself doesn't end here. Myself goes to other selves because I have to sell that product, or that product has to be satisfied by, I mean to say, other person who's called customer. That customer has to use or consume that product and also consume services. So what system I devise, if that party accepts my system, that consumer accepts my system, even under there is no alternative, in completion can say that service must be availed by that person, and that consumer must be satisfied. We sometimes write customer satisfaction is our policy. Yes, in beginning it was fine because people wanted business, they had to seek business. But now I think it has become a writing only, customer satisfaction. They write a lot on these policies, and then they write certain conditions also. Means conditions and those you can say claims that we deliver customer satisfaction. This nullify each other. We satisfy you. Customer satisfaction is our target, is our policy, is our destiny. But those disclaimers are also put in same time that we are not responsible for reasons which are beyond our control. This means this statement is nullified by other statement, and customer cannot understand at time of purchase because customer is very common. Everybody cannot go into details, and these are so small fonts that nobody can read, and how many times shall you read? So if we say indirectly we are held, and if you want to return that product due to whatever reason, it means you may have to do so many formalities, and that shopkeeper or that seller look at you at different eyes, eyes collimation, eyes vision. When you bought product was welcome, it was welcome vision, but when you return it or you complain for that, that is conditional. Means it depends upon how that seller, because seller is involved, question goes to profit. If product is returned, when sale is gone, profit is gone. And that may try to say I have to send this product to company and this and that. Means that negotiation is different now. Therefore, I would say we have to be smart. Every person has to be smart. Systems we write, we should follow it. Individual quality must be there. If individual is not expert, then individual is not required. Or you may say, individual has to understand what is required. Product quality I was talking, system quality I was talking, the attitude quality I would say, what is customer attitude and what is seller attitude, both involved. Sometimes customer doesn't understand and seller takes it right. Okay, I have sold it, my duty is over. Customer doesn't understand, very welcome. Don't answer, you're welcome. But every customer cannot read, every customer has some time. And customers, okay, what to do? I have no other alternative. I think people don't even read what is written on those products. They just go on buying. Nobody is worried about quality because people don't understand quality, and who they don't understand what's required in that. And there are so many products in life that you can't go to that level for every product. Now commitment is only spelling these days. There is no commitment in fact. I have many examples. I bought mouse, and this was, I can say e-plug it was. That it was, I think, 1 year, 1.5 year back, or more than 1 year back. This seller, this shopkeeper, when I bought, I went to buy it. I wanted HP, but says, no, you try this. This is very good. This they are promoting, and it is cheaper. Okay, I tried. I bought it. In beginning, it's okay, and when I read its content, it said so many million times you can click this. Okay, I was impressed that they are even counting millions times, 1 million, 2 million, how many millions. So it's great that at least that product producer is, the manufacturer is so much inclined towards performance. I was happy that at least, let us see, it worked just I think around 1 year, but its gear, its rotator did not work. I was upset, means I purchased it new. I went to that shopkeeper, and shopkeeper knew me. Okay, he said, no problem, give me back, I'll give you another one. Okay, I was happy that shopkeeper is responsible. Shopkeeper accepted that this product is 3 years warranted, and he even took that product and gave me a slip also, receipt, that will give you another one. I said, then I had to stop my work. No, he just replaced. Okay, he said, temporarily you take this one, other one, and when I return you, then you replace me, you give me back. Well, I was impressed that the shopkeeper is very nice, that understands responsibility. So I came back with that, and then I again, that person came to me due to some repair of my computer. Then, so I'll give you back this e-plug at home. And when the guy came, what happened? He says, no, I can't give you back e-plug because that party doesn't exist, or what is, I do not understand. They are not accepting, or you take another one. What I mean is, you give me back the one, or they give you another one. They give me another one. So what is responsibility then? If you cannot give me same product with renewed one, you was okay, take another one. Well, I had no option. I said, okay, fine. What to do? I cannot solve it. Still, that which was replaced, another one, is again causing same problem. And it's not even 2 years over when the guarantee was for 3 years. What I'm explaining to you is, these are all fake sales, all fake warranties. If you want to return, they don't want to accept this. They say we will do it, but they don't satisfy you. Means you have paid for 3 years warranty, but they are not able to fulfill that. And where it was written how many millions click this can do. I can't count clicks, but millions is big figure. Even if you work for 1 hour on your system, you will not click. You can understand how many clicks you have done, how many pages you have opened. Means, is it easy that you complete? Means, I'm going to that details which these people befool people. These field manufacturers befool public. Write something and tell them so how many clicks it can do. Now, how shall we estimate how many clicks have been done, performed? That's what I say. So commitment is not fulfilled. The commitment was for 3 years or for so many clicks. Now I have no record of clicks, but 3 years must be there, which could not be completed. That's what I'm saying. This is a part of quality system, and it doesn't work. Then there are other parameters which we have to care about in quality, and we move further on to that. This designs of structure is another, because I am dealing with structures, engineers deal with structures, also mechanical engineers, this is machine structures, machine designs, electrical people deal with their own system, transformer designs, switchgear designs, and other designs like distribution boards, load calculation, all that they do. How much electrical load shall come on this building, on this project. They calculate like we calculate our loads, they calculate their loads, and similarly other disciplines too. So it's total system, it's total theory, it's total practical theory of designs, you can say theory of analysis, theory of structure. All these come into picture. Ultimately, you can say directly or indirectly, mathematics is involved. That you have to calculate electrical load, you have to calculate HVAC load, you have to calculate this load and that load, you have to calculate dead load on structures, live load in structures, you have to calculate other loads, wind load, and seismic, etc. We have to do. That is very normal. There is nothing new in that, and everybody knows according to your own discipline, according to your bench of engineering. So designs of structure and others must be qualitative and reliable. Design procedures exist, theories exist, everything exists, but thinking doesn't exist. Nobody can teach you thinking, nobody can teach you dedication, nobody can teach you commitment, and nobody can teach you involvement, and many more such criteria, requirements. Nobody can teach us. We have to learn ourselves. How you have to live, nobody can teach you. How you have to move in profession, nobody can teach you. And what is your goal, nobody can teach you, nobody can tell you. We have to decide. Everybody has to decide. Every person is different. Yes, education is common, it is uniform, but how much I can get from education, how much I can depend on that depends upon me. My will, my determination, my dedication, my concentration, my involvement, my objective. You may say, you may write or speak many more such points. That is where, a person is involved, individual is involved. Researches are done, innovations are done, not because of education. Yes, education is one point. Education is learning point, is knowledge point. But devotion, dedication, commitment, destination, or you can say pleasure. Some people get pleasure from work, some don't. While no work exists which doesn't give you pleasure. Pleasure comes from work, and some don't enjoy that pleasure. Some are physically oriented. They must have physical intimacy for pleasure, and some people have mental intimacy with pleasure. It depends upon what is your pleasing standard. Some people are happy to use mind, some people are not happy to use mind. Some are happy to be physical, some are happy to be mental. Mental doesn't mean mental sickness. Mental means use of mind, and when I say physical, it means use of body. Both have their own. Some people lie in between, and some are so brilliant that they say my mind is my spouse, my mind is my life, my mind is my result. I believe in mind, I use mind. Again I say, education in profession, even in engineering, cannot equip with all these qualities. It can only give you knowledge by reading 30 to 40 subjects in degree, maybe 40 subjects overall. We get lot of knowledge, but We are not committed to all these subjects. Hardly I think everybody has interest in one or two subjects in whole life, in whole education, depending on interest. And we move in that life. Of course, we have to pass all subjects, that's mandatory. But passing is one part, learning is another part. Passing doesn't mean that I have learnt it. Yes, I can understand it, that's meaning of that. If I say I passed it, this means that I am open to receive it, I am open to study it further, and I can move in. But there are people who in fact study those. So there are difference in learning, in passing, in studying, or in climbing into complete structure of that subject. In our engineering, civil engineering, structural engineering, we study many subjects, but we don't use all subjects. For example, we study electrical engineering, mechanical engineering, thermodynamics. Like that, we study many more professional subjects, but we never use electrical engineering, mechanical engineering, or applied thermodynamics in practical life. But understanding is a must. Our subjects are very limited, like the importance are construction engineering, foundation engineering, or you can say survey engineering, or we can also say theory of structure, design of structures, likewise geology, means which are of use. And out of these also, some are only happy in construction, some are exclusively happy in surveying, some are happy in designs and theory of structure. It depends. And some are interested in none, interested to survive. So it depends upon, I say, commitment, dedication, individual property, engineer future, individual's requirements. So designs of structure is very important subject, without which we cannot do anything. We live in structures, we think structures, we work on structures, we construct structures, we talk of structures. That is civil engineers done. They do structures, and that's our life. Construction of a structure, design of a structure, thinking of structure, a modification of structure, structure and structure and structure. Without that, we can't survive. Everyone, civil engineer, and some only draw their future for making money, and some pull their future for something else. Making money is one criteria, learning and reaching somewhere else is another criteria. When I think of structure, I think differently. I think that I consider that without structure, we are nowhere without structures. And structure doesn't mean structure. What we mean by structures, we don't mean that whatever structure, building structure, flyover structure, or you can say nuclear reactor structure, refinery structure, plant structure, bridge structure. Means there is no dearth of our field. Every work we do is meant for public use, private use, and it is supported by services, electrical, mechanical, security and others. So our structure is that type where we have to think a lot. That thinking which is done in structural design and construction cannot be even realized by common people who are not from engineering field. Those people do not even understand what behind scenes engineers do, and that's the only reason that they always blame if there is some failure of a structure anywhere or everywhere. They still blame engineers in one way or other. And I am happy that engineers are to be blamed in that case of failure, but they should also be given credit in case of success. Well, no problem if we don't get credit. Ultimately, we do work and produce structures, that's enough. Failures actually cannot happen in engineering. To be very frank, speak frankly, there is no way that structures fail if engineers work normally. If I work normally in designs and in construction, there is no reason that it goes in failure. No reason. But it happens, and that is not because of knowledge. That is because of negligence and because of ignoring responsibility or taking it lightly. And we know that hundreds and thousands of hands are involved in our projects. So we are sometimes we ourselves do not know how something has happened. How something has happened, we do not know. That's also true. Means nobody can expect that something would happen adversely, but it happens. And it's also true that even in designs, I can say there are so many hands. If one does design self, calculate self, and detail out self, and make drawing self, I think that will be much better than involvement of a group. Because when people work in group, I do something on this drawing, other guy does something on this drawing, so there are chances of failure of coordination, failure of connections of details, and that's why something is missing. That is because of that. If I do something myself, I would check myself, and I am sure that very few errors could be there. But if same drawing is handled by 4 or 5 persons, certainly there will be mistakes, there will be errors, and which are not actually pointed out, which are not even uncovered or discovered at that time, or which are not bulleted. And that's when it goes on and on and on site during construction. When some problem comes in due to that, work stops due to that, or mix-up goes due to that, at that time it is known that something is wrong somewhere, and then we say yes, it is there. And maybe at that time that person who worked originally on that detail, that person doesn't exist in that company or organization due to change of job. So it's very important point. I heard many times that engineers are those who work themselves for every detail. Better are those who think of structures and calculate themselves, design themselves, and produce the drawings themselves. Though they cannot give efficiency to that limit, to that speed in which group does, but errors are also very limited in that case. Smart engineers are those who design during their work, on work, means you try drawing also, you try design also, you try calculation also on Excel sheet or on your AutoCAD, or if you are using your software, you can do on that. But remember, it's question of time. If your system takes 1 hour for some activity in designs, maybe I take 2 hours, 3 hours, because I want to do it differently from first principle or from original method. I can save time by computer, but when I exclusively depend on computer software, I don't earn experience of assessment. Assessment is very important. Whatever result is given by computer, that result is very difficult to be comprehended. But whatever work I do by my own self, I know where I stand. And that's where you can say a kind of proof result, proofreading, though it's now formal that proofreading is done, but who does it? They are not field people, they are different. And those they are there, they never worked in field, they never have practical experience, they are only design born. So what I say, design is also different in different circumstances. There are people who only spend whole life in designs, and there are people who spend whole life in construction. Both have their own experiences. We cannot mix up those. But engineering is completely learnt only when you start it from construction and move towards design. That's my understanding. Because when I mix up these two studies, these two fields, I know problems in both fields and I know actions in both fields. Both fields are important because without designs, construction cannot be done, and without construction, design cannot be understood or realized. That is what, and both require quality element in that. If these are quality free, we cannot justify anything. Designs lead to physical construction, and physical construction tells where error was, where problem was, where complication was, where was problem in constructionability or constructability, where problem in ease of doing job, where was expected lapse in quality. For example, we can see there are hundreds of locations in structure that we can't pour easily. So much congestion of steel reinforcement exists there at joints or otherwise that even your vibrator nozzle cannot penetrate in. So that's a question mark. Means your designer cannot think site problem. They involve actually to create problems by their own vision, right? They have their own limitations. Due to that, they create such problems. That's the reason when I was saying designs are not simply design procedure. It's not simply design, you design in offices, sitting in rooms, and then say, this is great design I've done. Design may be great. Of course, I understand you have worked hard on designs and you have produced some excellent piece of design. We respect that, but that design is not simple design. That design is not end product. That design is in between product, in between construction and initiation, that has to be implemented through construction, and that is more important. If that design is not too easy to be implemented, to be executed, it causes problems, and I consider that that design is not worth, it's not quality design. Quality exists everywhere, as I said. It exists in design also. If operation of design is not well defined, if problems that exist on site or that could exist on site due to your design, a designer cannot foresee, then question arises. Means designer is not having any experience, he doesn't have experience of work on site, but only in designs. This means there is a void, there is a gap between construction and designs. That gap is not required in work. If designer has no construction experience, then it is also better if designer talks to those people who have that experience to get certain points where problems can erupt in. That's very important point. You may call it coordination, you may call it communication, you may call interaction, interface, whatever you can call, you can name that term. That is very important point in construction, in designs. Designer and constructor both are in same line, both have same objective, destination, and if both understand each other, both move together, then many unexpected problems on project can be solved, can be resolved. One has to depend on knowledge of another one. Designer has to realize practicality of construction, and constructor has to also realize that some complication of course would come, but not that type of you know complication in design that would create construction problem. That's why it's very easy to say constructability of work. Constructability, ease of construction, you can say. Construction means quality construction. If I can do construction with ease, with quality process in, with quality criteria in, I can say that is requirement. Quality is understood by everyone, I understand. It's not that site guys understands quality, guy understands quality, design guy understands quality. In fact, everyone is an engineer. Quality person, design person, site construction person, planning person, all those estimation person, all those who are involved in one activity or another activity, in one discipline, other discipline, they all understand what is required, what is engineering, because basically all are engineers. There is no way that they can be non-engineers. It's very important point we have to understand. Engineering is defined that way. Engineering means use your mind, think on, use your mind, and that's very important point. I can say think on, as I usually say in this, that thinking doesn't cost anything except time. Thinking doesn't cost anything except your knowledge. And thinking means use of mind repetitively. Concentration comes from use of mind. And if you use mind for same thing, in beginning maybe I could not find any answer to my problem. But if I go on thinking like that, certainly problem would start to be solved. Problem will start to solve. Because your mind works, if you don't, sometimes your mind works, it grasps something, it has system in it, inbuilt system in our soul that solves that problem. That's what I say. Explanation is always different. Thinking, I can use it as a formula, I can use it as command, I can use it as direction, I can use it as my own teacher. That thinking pushes me. When I have problems, I am not able to solve an urgency, then I get nervous. But state of nervousness of an individual can be, you can say, neutralized by process of thinking. Until you start thinking, you shall stay abnormal, like you're not in your concentration, you are not normal, you are not able to think, and that is defined as state of, you can say, panic. A state of panic. Your nerves are not normal, your pulse is not normal, and maybe you have low blood pressure or high blood pressure, depending on your nature, your body health. Which solution you have to adopt for that at that time, engineer does not know. It doesn't mean that engineer doesn't have knowledge of that, but that hidden file in mind is not able to come out because of a net created by your state of being panic, state of panic or state of nervousness. We have to think, and if you open your door of thinking, you enter room of thinking. And when that room of thinking works for you, and you start changing your state of nervousness or state of, you can say, worrying or concern or destabilized state, is again supported by process of thinking, and thinking continues until that state of nervousness is neutralized or finished, and you resume normalcy. That's where quality function has to be treated. I am saying that that's the only way, and you can experience that. No teacher shall teach you that. It's your own teacher. You are your own teacher. Because why you are nervous? That's the question. You are nervous because you cannot solve that problem. And if problem is not solved, work cannot be done. And then work is halted. That point you have to consider in quality criteria itself. I'm not giving much attention to quality of health, which is also very important for us. I was just thinking yesterday about that, though I think many times, but sometimes we have to think from safety point of view, and sometimes we have to think from design point of view. Design point of view doesn't mean that only designer can think, everybody can think. Requirement, everybody can think. Now, we have many experts' comments and many suppositions due to state of COVID in our country and its existence all over the world. COVID-19, I usually don't involve in this, but now it has come to attack engineering itself. We should understand that. Politicians cannot teach us this, other professionals cannot teach us this, and also journalists cannot teach us this. We have to teach ourselves. You may ask why you are involved in COVID-19 issue with engineering design. It's not my instance, it's automatic. There are so many, you can say, theories, so many assumptions ongoing, particularly for high-rise buildings, multi-story buildings. We are engineers. Already design formula are there, planning is done, design of houses is done, architects do their job, but there is no patent on anything. Every engineer has a right to think and right to design. Everybody has to design something in mind, if not in papers, and if you can design on papers also, that is excellent. Because you are a human being, you have same mind as architect has, but you have better mind than what architect do, because you see practical problems. Every engineer comes every stop problems every day. Now we have to think about how COVID-19 can impact in works. As we said, it impacts through safety, discipline, and also it impacts through design of architecture and design of structure. Both are dependent on each other. We live in our residences. We use air conditioners. We use toilets. And our buildings are mansions, maybe 10 story, 20 story, 30 story, whatever it is, high rise or low rise. If it is single house, plotted house, well, it may not cause that much problem except for air conditioner use. People say, what do you mean by that? People want to use AC because to extract or to draw comfort from that. Comfort is also a very important part of life, if you can afford it. Because we don't want to use nature, we want to use AC. That is middle class and higher class tendency. Better than use of mechanical means for air conditioning. Natural air condition is far better than that. But we believe in machines. Okay, I don't mind that. Air conditioner is a comfort zone. We can use it. Indeed, no problem if we can afford it. But my point is different. We have to consider that point. AC, it may be wall mounted, it may be central air conditioned, or it may be indoor outdoor split, or whatever other method we use in cars, while driving cars, or buses, or flights. AC is a part of life, particularly in higher temperature areas, or even in lower temperature areas. We heat up. We say HVAC means heat ventilation air conditioning. Heat ventilation air conditioning. We have to either cool down or heat up. In both cases, machine does its job. Air handling unit, chillers or evaporators or whatever we can say. Our environment surrounds us. Where we live, where our machine of AC is fixed in, or we don't feel that. But mechanism of working of AC claims it, says if there are compressors in that, compressors, evaporators and such machine which while working can pull air into room. It can pull air. It can also pull water part in air, though that is drained out, but it can pull. This means that machine, it will be called compressor, is strong enough, is having good strength to pull that heavy item. Air which is not light we can't consider. It's heavy because it has water, moisture. Now I consider this because I am talking of COVID-19 particle, not COVID-19 impact, particle. That bacteria you may call it or whatever you can call it. I don't know what is that virus. But I came to know from various resources that its size is very, very limited. Its size cannot be seen by naked eyes, and sometimes it cannot be seen by your microscope, but it has some size. It's very light, much lighter than water, much lighter than air, because if it is heavier, it cannot stay in air, it cannot move from one location to another location, but it moves. This means it's somewhere, you can say, too small, just like a particle of dust in air. When you see dust storm, what does it mean? Oh, you say it's very dusty, 140 km speed of wind and 100 km speed of wind, and sea, sky, sea, air is dusting. What does it mean? This means that your dust particles remain suspended in air for long. This means if you consider one particle, forget others, one dust particle, and want to know properties of that particle, it's very difficult for everybody to understand. Sometimes that dust is like smoke, like fog. So imagine the size of that particle. Technically, you are an engineer. You can understand very well what that size should be. And that's important point. Very important point here. We have to consider that. Everybody cannot consider that. When I take example of clay, Mount Morillonite say, its particle is very small. And we usually say 0.002, right? That size of particle. These particles are connected together cohesively. This means when this is dry, there is no water, and wind blows at a speed of 60 to 100 to 150. This clay, dust we call sometimes, which is dry without water, it can fly. It can move into air up to some distance, depending upon density of air at that time and density of your dust that time. Lighter density goes as high as possible. You can say even up to many, even up to 20-30 meters it can go to, 10 meters can go to, and you cannot see anything. You cannot see, say visibility is very poor for time being, and all your cars start using hazards, lights, fog lights. My inclusion of this talk in this is because that is main point we have to think of for virus. That's very important point of thinking about COVID. I'm not going to explain what COVID is. That can be I have explained many times, but simply explanation is also not important. You have to understand that. That point is very important. I want to see if I can get that file. I am not able to see that file. COVID file. Let me see if I can see. Sometimes files are very important to refer to. COVID-19. Oh no, this one. The other one. COVID-19. COVID quality, COVID, I think I got it, yes. No, it's not that one. Sometimes really confusing, I don't know why. I think it's there, right? COVID-19 action file. Not this, not this, not this, it's that, I think it's this. Ah, yes. When I deliberate on COVID, means I'm now involving this COVID in my engineering, civil engineering, design engineering, and of course we have talked about HS engineering. HS is one part of our engineering, and design is also there. Safety of this, safety in designs also you can say, health safety. Now I talked of frontline workers, but I'm just trying to show you this file from design viewpoint, means how can we, when I say here somewhere, well, I did not write there, and that is not able to meet demands. I think I did not include that in this. Probably no problem. Just inclusion is one part, but let's go to C. That's what I say. Bharat, India, in real trouble. Facilities issues are significant. Facility also I can talk. Facility I'm talking about. That is also important. I last time talked about this. That is, let me repeat it better. It's safety issue. It's responsibility of entire engineering professional community to contemplate on working issues, site working issues that would be impacted upon due to additional protective measures requirements. Okay. So many activities are critical in a sense which do not permit. Okay, fine, it's okay. Well, I think I did not do that in this way. I include that one later on. Now I don't have time for that. So here you can say, let's take, if I say I have to design some home, some residence, it may be single story or it may be a multi-story high rise. Engineer has to start thinking now is time, real time. Design is one part, but planning is also a part of design, which says that if I have to design multi-story building, structure design is not affected. I'm not saying about that. What I'm saying is, say I have toilet, bathroom or washroom or WC which are linked to sanitary stacks. You know stacks, vertical pipes connected to our waste of WC, night excreta for WC, or bathtub or bathroom or kitchen. All these are connected to stacks, external stacks, which may be plastic pipes these days. In past these were sand cast iron pipes or cast iron pipes. Now these are plastic pipes. Now I'm not talking of material of those, but I'm talking of function of those. Now this back of virus says that this virus, which is too small, as I said, lighter than clay particle. This means that may 0.0002 or 15 is smaller in size that even your electronic microscope cannot identify thoroughly. This means that particle can be pulled into your room. Point number one is effect of AC, means this particle can come to your room through service of AC, because AC has compressor in this. Compressor is quite strong to pull air as well as sand particles, water particles. So this particle is nowhere that it fails to pull. No, it will pull successfully. This is one point. How we have to see how to handle that if this particle comes into your room. And second consideration is, second point is, you are going to use your wet areas, as I said, washroom, toilet, WC or bathroom will separate, and also your kitchen waste. All these are water linked. You are getting water supply into your wet areas, and also you are disposing your excreta through these pipes. Both are wet areas, both are water linked, somewhere excreta linked, effluent linked. These are services we provide in buildings. Now water supply, if you have no control on storage, or water you are getting from somewhere else, there is no control, then your water can bring with it this bacteria or this virus, and you don't even know. And those people who are involved in water supply system, water supply distribution system, they also remain ignorant about this. And also your tank on roof or underground, or even if it is pressure piping, tank is on ground and that is filled in, and pump works to distribute water into all floors. This means we can provide facility to help this virus reach tank, water tank, and that also reaches to your bathroom or your wet areas, and also through your system, stacking system, sanitary system. This can move into whole stack and other connecting stacks. Means there's a great danger that such a height stack, sanitary stack, receiving waste from 20 flats or more, or even whatever number, 10 flats, there are chances of big circulation of virus within that stack, within water supply system. It moves in, and everywhere water supply is not hot. It's not possible. It's natural water content. It's natural temperature of water pumping. So what can happen? We have to contemplate on that. That's very important point of new way, I can say. Should we keep stack whole in one stack? Should we keep disposal pipe into one stack, or there should be now, because we have to reduce chances of spread of this virus through homes, or we should keep 2 or 3 disposals of flats into one stack. If it's 10-story building, then you need to connect each area with many stacks. Now that point requires attention, very great attention. Maybe I say that there's a probability that we can reduce, or you can say it's a kind of lockdown of stacks, permanent lockdown of stacks. We can lock down of stacks. Either we have to change our system. We don't believe in multi-stories high rise. We keep ourselves limited to 3 stories probably, but that is not going to work because of so many reasons. So my point is, why I am telling all this? There are 2 points I have discussed. One is for air conditioning and other is for our flat system, our wet area system. These are generally joined and connected to each other, because water that's supplied in homes, that is also discharged through drains, through traps, flow drains, again to sanitary units, and then it moves to manhole, sewer system or septic tank, whatever we have. We have all this. We have to, when it is pump supply, it impacts very much. We have to see if we have water tank located on roof, it also causes same problem. And also if we have water tank at ground, what sort of problems we can have. We have to contemplate on that, because it's a part of practicality now. It's not book design, it is problem based design. We have certain problems, and this problem may go or may not go, that is a different issue, but whatever has happened must be checked. So we have to see that. Means how many flats can be connected to one stack, that you have to think now, as minimum as possible. This means if there are 10 flats in vertical arrangements, 10-story high building, and you say I decide to use one stack only for 2 apartments or 3 apartments, so in place of one stack you have to require 3 stacks now. This means if we say 3 stacks now we need, means you need that much duct area, or shaft you call it in our language, I call duct. Means you have to use bigger size of duct, widened duct, which means that you are going to use lesser coverage for your apartment, and width of duct is increased. Maybe it is 2 times, it is 3 times than previous one. If you are lucky, so I provide 1 stack for 3 flats, because in plotted houses generally 2.5 we call it, or 3 stories allowed, and that we use single stack. So I say this, maybe this building is 9-story or 12-story. So in 12-story we can say 4 stacks are required. So your single width of duct which you had now has to move to, you can say, 4 times of that. No other way. So you have to design units in such a way that your bathroom size will be affected, your toilet size will be affected. Of course, because you have to increase duct. In somewhere you have to increase size of duct, and your design will be affected. That point we have to understand. In place of one stack, there may be 3 stacks or 4 stacks. More if it's more higher. And it's more higher means more dangerous. So keep in mind what I'm saying is at very initial stage. It will time people take to think of, because still people are not thinking. Engineers are out of thinking. I don't know reason behind that. If life moves, if people are alive, only then engineering can be done. If people are not alive, for whom you shall do engineering? That's the point. We have plenty of literature on designs, plenty of literature on theories, but now something new is coming. We have to handle that. That's one part, and other part is we are ourselves responsible for procuring in this virus because of use of compressors in air conditioners. Compressor is very heavy instrument having good bhp, and you can say it can pull, it can suck, you may say, rather than pull. It can suck aerosols available in air. It can bring this, it can transport this virus into your machine. It may be air handling unit on roof, or it may be something else. These pulls, these particles, small particles, these come into your machine, and they enjoy when they enter machine. For example, chiller. In air handling unit, I think they will not enjoy because of suction. This is a little high temperature. But in chiller they will enjoy. Life will be easy for them in cold weather conditions, and they may generate some skin issues, or they may have to face issues which I am talking about. It's very important point, you can say, very important point from that aspect we have to consider. And before going further, I think we have to I will be 5-10 minutes, I will come back, and I come back and do it for you. It's very, very important to go and come back, to go to roof for 5-10 minutes. You have to give a time. Meanwhile, you can read this document. It's for you. You can read this document and think of what to think of. It's about building engineering designs. Sorry for the moment for 5 minutes. Not much. So we have to continue on this issue. We have to continue on this issue. I was talking about two issues. One was air conditioning issue, other was sanitary issue. Both are important and we cannot do without that. It's very, very important point. We have to understand these two issues. Certainly we have to understand. There's no way that we can go without that. Now point is how much we can move on that. That's the important point. And when I say that we have to consider in our design size of duct, which means we have to enlarge our duct size. Width is not an issue here. Issue is one length. Maybe you have to make it 3 times, which means your size of bathroom will be affected or room would be affected. Or you have to take different locations at various floors, or you have to stagger your bathroom sizes in 3 one, then another 3 other one. How you do it, that's part of design. Means our principle may be that three floors be connected to one stack. Other 3 floors may be connected to other stacks, like that. This means it's not necessary. Means it's not easy also to stagger, or you have to make dimensions such a way whole design will be affected. We have to think on that. When we work on designs or planning, then we have to think on that, how to do this. This is a question for everyone. Should we reduce stories? Should high-rise should come to multi-stories? Now this is a great question. How to handle least disposals from, you can say, minimum, you can say coverage, minimum, you can say minimum number of floors to be disposed of into one stack to avoid facility given to virus. That's the important point. And it depends on when you design. It's very important point. We have to design. We cannot take it for granted. And also about air conditioning, when we use air conditioner, is there some way that virus doesn't come in? I think there is no other way. It has to come in. It has to come in. And now people are saying that keep your ventilators open, keep your windows open. Well, I think that is not going to work properly. They say only. But we should understand that if we keep our windows open, our ventilators open, and work, our AC work, this means additional load shall come on to electrical consumption, and also to cool air. Quantity of cool air, which call in tonnage, that would reduce, and moreover we won't feel that comfort we find in AC. Means this is a complicated issue. Means you want use of AC and you want to keep your ventilation or your windows open. I think it's not right possibility. Or we say completely avoid use of AC. That is not possible for people who are born in AC and who can't even think of AC. So it's a big question mark. How can we prevent that virus from entering into our system? We have to think about that. Or all time we have to take precautionary measures in our room while using AC. That's also not possible, because in some AC accommodations, it works whole time or it works continuously for hours. And when you say you have to use every time, you can say solution to spray, sanitization. You can't do all time. All time, after all, that's also chemical. It can impact on health. It's very, very different question. When you drive car, you have to keep your AC open because of so many reasons. And if you don't use AC, then you have to open your or keep your car windows open, bus windows open. And how can you deal in flight? You cannot keep them open. Well, there are very issues, engineering issues, which we have to understand. And there is no direct answer to that. Flats, we can change sizes of rooms, and we can say, okay. Then you may say, okay, chances are very rare that aerosol may be present. How can you say that? This assumption that may not be present, but we have to assume it is present. We have to find a method that it doesn't come into room, and that method doesn't exist. If it doesn't come to room means then water also cannot come to room, moisture also cannot come to room, and air also cannot come to room. If it doesn't come to room because it's much lighter than air. Now these are certain critical questions. Water supply, sanitary, and air conditioner. These are all services to buildings. But these are question marks particularly for buildings. I'm not talking for flyovers. I'm not talking of water resources. I'm not talking of dams. I'm not talking of something else which have no problems as such. Air circulation is a problem. If particle enters my room, it will not go away, and I won't know it. It will infect us. What is alternative to that? And we know that this particle dies at temperature of more than 90 degrees Celsius, and that temperature can't be kept in room. If that temperature is kept, means it will roast us, or if it doesn't roast us, that means we can't stay in room comfortably. Point is, means we are used to stay in air conditioned room at average temperature of 27 degrees or 24 degrees or 25 degrees. We are used to stay in that temperature, and we can't move without that. So what is solution? That point we have to think. That is what I say, COVID-19 impacts on safety, health and environment, and this AC room is also an environment. Temperature, air conditioning, or can we live without air conditioners? That is another point of view. People won't expect this and won't accept this. How to stay without air conditioning? Means those who are born not to live without air conditioning, it's really a problem for them, real problem. For those people who can live without that, they can use air rather than AC. They can use air coolers, they can use fans. That's possibility. We have to think about that. Means how best we can move, how best we can avail our knowledge to this. I am sure that it's medical issue, it's chemistry issue. Can we neutralize or can we use different type of refrigerant, which I think I'm not sure, or can we use some other gadget in home which can neutralize the effect of that? That's it's not clear. So this is an issue, air conditioning issue, one issue, and the circulation of water and excreta in system. What to do? We can reduce stacks, okay, to some extent it may reduce, but we have to keep in mind same time that stacks finally dispose it to single sewerage system. Even if there are 3 or 4 stacks we provide in verticality, it's okay, but ultimately this would discharge into same manhole. Or we say we have to spread, we have to make many sewage lines for that. That's not going to work. It's not going to work, because even after that, yes, if your sewer line disposes into, you can say, containment, or into sewage tank, or into septic tank, which is not general point in apartments. There is public sewer, and that sewage, when I say sewage, means there's material flow, excreta liquid flow, that's sewage. And when I say sewerage, it is system of pipelines that carry sewage. Just keep in mind sewage and sewerage. Sewage means material involved, excreta, and sewerage means system. And this sewage, which you call, if it is used, it's allowed in septic tank rather than containment, then it will convert into effluent as well as sludge. That we know. Sludge and effluent. Effluent is disposed into pit, it's called some pit, and also you can say your excreta, which decomposes to sludge, is taken out from this tank. Or if it is containment, that is different issue. Containment, there is no decomposition in containment, there is nothing, and this can be pulled out, this can be pumped out by machine, by tanker, and taken away to dumping site. That's the only possibility which is done. But about this design, there's a question mark, so we should understand that. We should understand that design, and we should understand our requirements, and what are requirements we have to keep in mind. Now, quality requirement, and this COVID I close. I think I've talked of this, so better I close it now. So this also one file is follow-up, that is building engineering designs, which I discussed before also, but this is such a subject which can be taken up many number of times for further explanation. Building engineering design, scope of you can say firm, then building services, and it is then detailed engineering design, services designs, specialized designs, specifications, supplement specifications, coordination procedures, coordination between contractor and its head office, coordination between contractor and site office, then you can say coordination between contractor and firm, and coordination between contractor, firm and EPC, and there's a coordination between firm and site, contractor internal coordination among various sections, likewise review and approval of documents, CAD procedures, and engineering reporting and change control, then documents control procedures, vendor print, numbering, review and distribution procedures, as-built drawings, inspection and test plans, project controls, procurement, pre-mobilization planning, work centers, mobilization, subcontract strategy, testing and inspection, material management organization, procurement, corporate organization, site organization, workforce recruiting, resourcing and mobilization, and like that, construction method statements. Means this way we are going to talk a lot on this. There's so much in that you can see. This can see further, you can browse and you can see. And then method statements likewise, So we can see there's a lot in that. We can learn, or we can refresh, if not learn. Yesterday I talked of something. I was talking of quality requirement, and we had covered certain points in that. I think I was on lift, right? No, that's too far. I've gone. Lift well works. Okay, this was that. This is important item. Important in a sense that you have to understand what I'm talking of. If I can say, I like to go there only. I want to see this file. I want to see that file, and that is method statement file. I'm trying to find that file. Lift. Wall forms and lift form. Yes, it was that. So lift it is, and I was talking, you can see again this sketch explained yesterday that we have this proposed concrete, and this is lift well. These are walls, RCC walls, and if you see here section, this is lift pit, this is plinth level or ground level, and this is pit here, it's concrete here, and this is a lift valve, in which lift car will move out. This portion to lift has come down, and this base, and what is interested, we have to pour these walls in this portion. We have to pour in each floor, and there is door also which you have to keep out concrete. This is basic requirement, and I had explained you about how we have to do that, how we have to compute forces, how shall we handle it. All those points I tried to explain you in last video. It's not that easy as we think. It's a lot of work in this requirement. Let me explain to you that there are two stages in pouring in this lift walls in one story. I'm saying stages, I'm not saying layers. In one stage, this height is 2.2 meters, that is door of lift. Up to this we have to pour, and then from there onwards up to whatever height is there we have to pour. So these two stages, of course. In this stage, first one problem is that we have to cover from this jam location, going this way and coming this way, or we say start half this way and half this way come. And that's for height of this one. And next is about all of this. In that we have to take complete circuit, complete square into our port system, and we have to go above up to below slab. That's important. Or if you say there are beams also up to them. This is what we have to work on lift core. So I have written here insert door internal form, insert door internal form, and 60 ton bolts to be sleeved in and sleeve to stay permanent. Calculate forces for precision details are indicated. This is air, these are bolts in sleeves, and internal door. There's door which I have to keep as void, so it's an insert door, internal form which is here. You have to insert that here and tighten it. So there are two ways. One is complete 8 sides here. I have to do first 8 sides, and then we have to insert this shuttering here. This formwork here, this is both sides formwork. It can't be one side. It has to fit in. So this is, you can say, double formwork. And also like this double formwork here for wall. And you can see all of the details, same typical. As I said, this is void, and this is plates. This is a standing battens at 0.5 meter, and you can say 8 sides, 4 sides A and 4 sides B, elevations B, and this is normally done. So we can now speak about this. Let us see how does it work. It says, yesterday I read it again, I read it because it's an important one. We have to understand all time. It's better one if you understand all time rather than risking it. I don't want to risk it. I want to understand it. And that's the main point. So we can say, you can say that checklist for RCC lift well, walls, what? You can just, I'll be back in 2 minutes because I have to open door. I'll be back in 2 minutes, please. Just read it, right? I'll be back in 2 minutes, please. Hold on. So I say, now let us continue. It says, number one, let us start with this. Let us start with this. Let me close this file. Let's say, I read again for you. Ensure safe scaffolding with working platform is in position for access on both sides of internal and external areas of elevations, pertinent proposed walls to carry out preparatory works. Ensure safe ingress and egress to and from inside of lift. What is that? Is talking of scaffolding with working platform is in position for access on both sides of internal and external areas of elevations, pertinent proposed walls to carry out preparatory works, and ensure safe ingress and egress to and from inside of lift well. Ensure all other safety measures such as green tags are installed. Now let us see what I'm talking about. Is this a sketch here? Here we can say, for example, this is height of lift form and this platform is required inside, and there must be access which is not shown in this, that you have to raise on this height. You have to raise onto this height somewhere outside this platform, is not shown here. Access, a safe access, stepped access, and with scaffolding in both sides around. There's a scaffolding around here, all sides and insides around here, on which people can go up through ladder or through something else. Some, I think, steps, open ladder, staircase type rises and tears, and they can safely reach up to working platform inside and outside. That's what says, means inside working platform, outside working platform. That's the question here. So what it says, let's see. It says that ensure safe scaffolding with working platform is in position for access on both sides of internal and external areas of elevations, pertinent proposed walls to carry out preparatory works. So these are all preparatory works we are working for. We have to access. We're using scaffolding, as I said, and we will internal and external, both access must be there, safe access on which people can stand and work continuously until concrete is poured, and also ensure safe ingress and egress to and from inside of lift. So this is both we have done, inside and outside. We have to provide certain arrangements to go there, to reach there and stand there to work with all arrangements of safety, structural supports, and also vertical, you can say, rails around, with complete system that people safely work there, access to that place and come out of that place. And ensure all the safety measures such as green tags are installed, which means this system, whatever we provide for ingress and egress from working area, from inside as well outside, internal to external, this must be certified, this must be tagged in by safety engineers. That you can go and say that this is a norm of safety. Then you can say, as in, ensure reinforcement bars fixed and correct to design requirement. That's very much structural work, or you can say already bars are there up to starter. They are taken from pit. Now we have to fix all bars of reinforcement up to level of 4 meters and overlap further, or you say according to whatever given in drawing. You have to fix all those reinforcing details according to your drawing, and these bars which you have cut and bent according to bar bending schedule, whatever is there, and that reinforcing bars fixing or placing must be correct and should be in compliance to design requirements. Overlap should be fixed correct to specification requirement, no change, whatever specification requires, this should be there. Overlaps means 50 days or 40 days according to tension requirement or compression requirement respectively, and that's what we have to do. Then we can say yes, if it is epoxy issue, if it is epoxy coated bars, then overlap will increase by 50% normally, or if this is not epoxy coated bar, it should be normal. Or if we are not going to fix overlaps, Then we can also use, if permitted, or if we can say it's better, to provide mechanical connectors in place of overlaps. But in this case of lift, I don't think there's so heavy bars. These are generally 12 or 16 bars with 8 or 10 horizontal links, etc. So I don't think that 20 or more, 20 more higher diameter bars are used. So I don't understand. I don't think that mechanical connectors is a requirement here. But let us see. Just our consideration. And I say lowest link should start at half of spacing location from relevant lower structural floor level, which means that there's concrete below up to plinth level or grade level, and from there you have to raise. So say your spacing of rings or studs or this horizontal bars is 150 So first one should come at 750 and if spacing is 200 it should come at 100 That's meaning of this point. That is practice for better confinement, for better rigidity, and of course it's question of shear force as well. So in shear we do same thing. Ensure all placed reinforcing bars are well tightened, well fastened, and maintained plumb. Of course you can't check plumb of bars, but eyes can tell you it's in plumb or not. Better if it's in plumb, otherwise you have to adjust every time. All these bars adjusted time is to be saved. And if these are in plumb means bottom bar also in alignment, and we can adjust that later on. Of course there are U-shaped bars at corners of U-shaped bars. I told you yesterday also. U-shaped bars would be here. You can say at these corners U-shaped bars in both ways at 90 degree, like that here. U-shaped bars, here this way and that way, that we can do it. And you can U-shaped bar here as well, adjust possibly. So we can say that U-shaped bars, or even if so required, rings or struts be rightly fixed in position and well secured or anchored. Then we say ensure fixity in particular corners U-bars in both directions, making a perpendicular. Ensure reinforcing bars are clean and free from rust. That's very important point, I always say. That's very important point. I always say that these bars must be rust free. No engineer accepts bar with rust. That's not good and that's not permissible. This is going to be durable structure and we can't allow rust in that. So reinforcing bars are clean and free from rust, and if these are epoxy coated bars, question of rust doesn't arise. Also then we can say we have to consider application of sacrificial anode. Ensure sacrificial anode is fixed, means anode which is to accept oxidation of bars, means anode is responsible for that, rather than these bars are oxidized. With due controls, anode is oxidized and rusted, and I think there is a mechanism, it's made of aluminum, this engineering and electrical mechanism in that ensure sacrificial anode is fixed. This is cathodic arrangement, and if so required, in which case non-epoxy coated bars can't be included if we have to provide cathodic protection on these bars. And also ensure that electrical continuity check shall be conducted if cathodic protection is required. Electrical continuity check is done on all bars which are bound by cathodic protection arrangement or mechanism, particularly in critical cathodic protection case, where C clamps are used on each and every bar, and G wire goes up and down in sinusoidal curve, and each bar is connected which means current should pass through each bar, and that's the reason that we check continuity test, and without successful completion of continuity check, there's some error we consider, we can't concrete. Ensure touch-up paint is applied in case of epoxy coated reinforcing bars, which is very true. If you are going to use epoxy paint, not epoxy coated surface of bars where you would use, then there may be some erosion, some tears, something on surface of bar which we have to keep repairing all time until concrete is poured. And when epoxy coated bars are utilized, included, no question of, you can say, cathodic protection applies, because it is ultimately high level plastics, and there is no question of flow of electric current through plastic to bar. So ensure electrical and the required inserts are fixed and approved. Electrical inserts, conduits, electrical conduits, switches, switch boxes, or some other system, you can say, if required. I can't say at this moment, depends on drawings and designs. And whatever inserts you think are given must be placed in. That is important. And ensure all concrete spaces are placed at appropriate locations and positions on both sides of walls, forms, internally as well as externally, and on door jambs. Concrete covers the concrete spaces are already fixed on sometimes your steel bars, but these must touch your form, and it should be minimum because your steel bars are already fixed below and these are on top well tight. So if by inspection you think that there's enough margin, that there's no need of your steel bar and so your covers, concrete covers to stay there. You can remove many of them, and if you think on top of this there's a margin to reduce this and do something else, and you can keep on top of concrete level better covers. Those covers may not dip in concrete, but they will keep all system alive. This point you have to understand clearly. Concrete spaces are meant to keep concrete, external surface of concretes and steel bars with safe distance. And if I am getting that just because by fixing of reinforcement position, I just keep certain bars on top above concrete finished level of column or wall. And later on also this can be used for future. You can remove from there and you can put up above. So it's not necessary that your bars your spaces must be in concrete. It's not necessary. Position is important. These bars must have position from surface of concrete to defined thickness, defined distance. Now you can say electrical and other required inserts are fixed and approved, and concrete spaces are told. Try to avoid excessive spaces. Okay, that's fine, you can remove them, and check that these spaces are fixed on top portion out of top. I told it. Now ensure all inspections conducted before closing reinforcing bars by formwork. Check whether or not starter or kicker is inconvenient. Now preferably you can say it should be avoided if feasible to go ahead without it, using external confined support for that. So avoid it. And what's that? Check whether or not starter or kicker is convenient. Nobody likes kicker. If it can be avoided, there are ways to avoid it. I have done it. But if you know how to provide it, there's no barricade, you can provide it. It's only 10 centimeter or 15 centimeter thickness. It just gives you a facility that your form at bottom is fixed, but sometimes it causes a problem also in alignment if there's some error in kicker. then you may not realize that this problem is coming to kicker because you have no such experience. In that case, you can say, okay, let him come back. Then we can say, okay, let's go further. That preferably it should be avoided and the kicker if feasible to go ahead without it using external confining to formwork, and then in case we are able to remove or avoid kicker, it's better. Due to misalignment also it may cause some problem in formwork, and we have to sometimes chip one side or two sides. It's something is a problematic sometimes. In our case, proprietary system is used in place of site fabricated one. We have to follow details given by manufacturer of their drawings and there's no way we can go out of that because those drawings are based on real calculations. They must be available. Those calculations of direct load or horizontal load or movement, whatever they are calculated, and those imposed forces must be equated to provisions are made on designs about resistance of to these bending loads. If you have self-determined or self-designed system, you can use your design systems for which you are responsible. You must calculate forces and then resistance you are providing by your formwork. It's very important item because height is 4 meter and consider pressure is imposed on formwork and bolts. So whatever pressure is formwork on that, you have to limit that here. Now say self-designed system is being followed, ensure following requirements. You have to check your lift well door forms. In self, you can say what I can say in this case. In case self-designated system is being followed. Self-designated system is being followed. Ensure these requirements, which I am going to state. You can read also. Check lift well door forms are additionally fixed to be concealed within main forms. That's already told. I told you. Check both internal and external forms are fixed in position correctly. You have to be sure about that. Check side supporting system intact at one side when tight bolts are used. Check grids, offset thread lines are available, and check axis references on both axis references, x-axis and y-axis. Control axis, you can say, controls for dimensions for locations of grids. Those axis references, if these axes are not available on your drawings, then you can mark them, you can devise them. Because one point is better to control all axes in both directions, grids. So check from both axis references to ascertain all valves locations. Check tie bolts. Check tie bolts are fixed preferably inside of valve sections in all valve form. That is, tie bolts are fixed preferably inside of valve sections in all valve forms. Check that these bolts pass through plastic sleeve with bosses at ends, and bosses would be removed later on. and filled in with something else, some other chemical, construction chemical. Do not tighten them immediately, but after ensuring two locations and accurate plumb. Top inclined support is meant for keeping forms in position. I already said top support and bottom supports are meant for fixing form locations, sections, I have to say sections particularly. And middle support located and fixed at 1/3 from bottom is meant for resisting this resultant fluid pressure during pour. You know, H/3 is height of application of fluid pressure. When you calculate water retaining structures of fluid pressure, that's called WH/2. That is horizontal force intensity, WH/2, and if it's multiplied by H/3, it gives you WH²/6, which is moment. But keep this in mind, moment at bottom is this much, and this is the core. Then we can say we have reached that statement was check whether or not both tables have been designed to withstand forces imposed by liquid concrete safely, and check all corners of forms well anchored without causing any worry for opening and relocation of forms or getting twisted. We are talking here about this, these corners, and these corners. There's a pressure from this end, there's a pressure from this end. So this can go this way out, this can go this way out, and this can go this way out, and this can go this way out. They should not go out. You have to make sure. We'll tie them up additionally for inside outside. So check all corners and forms are well anchored without causing any worry for opening or relocation of forms or getting twisted. Also check internal forms. That should be provided with adequate cross inclined supports. Though located in middle of forms at various locations, and we have told you what is that. Very easy. We have to see them. Again I repeat, also check internal forms that should be provided with adequate cross inclined supports, though located in middle form at various locations. Check whether or not heavy plumb bobs are hung from top of forms on at least 3 or more locations depending on length of RCC work. Now heavy plumb bob means either use heavy concrete piece or brick or block, etc. You may have debris on site. You may have concrete pieces on site. After ensuring, says check location somewhere at middle, and before that you can say heavy plumb bob means either use heavy concrete piece or brick, etc. Binding wire can also be used to hang heavy weight. Timber piece can be fixed on top to hang plumb bob. First check form locations at bottom, then at top. Check location somewhere at middle. After ensuring form locations, check plumb on check plums in all locations vertically on full height casting. Check for adjustments if so required. Then we can say once forms are checked for horizontal and vertical locations, start fastening ties and ensure supports are well anchored. Check adjustments if so required to bring errors within permissible limits. Having completed all walls preparatory works, move for working platform operations and check stability of system. That's very important. Platform operations, which I showed to you here, internal as well as external. As internal one, this platform, of course this internal supports are sector, but this platform is there up to this level where you have to stand, where people are standing by pressure capped. You have to work from here downwards. Here concrete go up like that. These supports I told you, this support and this support are for keeping this top and bottom in position, whereas these are internal support which are to keep resisting forces of pressure comes onto that. So this is that simple. We have to go back to, it says that once forms are checked for horizontal and vertical locations, start fastening ties and ensure supports are well anchored. Having completed all walls preparatory work, and you can say having completed all wall preparatory works, move for working platform operations and check stability of system. We can see then having completed all preparatory wall works, move for working platform operations and check stability of system, plan for inspection and pour accordingly, keeping in consideration casting wall at one time, not more than 400 mm layer. Check adequate working space is available within walls preparatory works, about passage of pump pipe movable down to at least 1.5 to 2 meters in above for purpose of controlling segregation. Now above lowest contact starting point, check for raising a strong temporary platform internally as well as for external works working out. This is normal I show to you, and remember that concrete pour in well is slow. It's slow around walls but steady, as it has to be poured in rotation of heights not more than depth of nozzle. It would risk opening forms in case pour is allowed faster in one vertical go or two. Wall is not an element like columns or beams, and therefore imports a good check and attention. Then you can say lift well valves are a complicated bow item that should be taken care of, due care of. Must work out concrete fluid pressure in posts and forms at every meter vertically and ensure that provided system resists all other systems. Okay, then we can say must work out concrete fluid pressure in posts and forms at every meter vertically and ensure that provided system resists all forces safely. Reinforcing bars particular requirements, and that is ensure reinforcing bars are clean and free from rust. That is main requirement. And ensure reinforcing bars are clean and free from rust. Also ensure sacrificial anode is fixed. And ensure sacrificial anode is fixed if so required, in which case non-epoxy coated bars shall be included. Ensure that electrical continuity check shall be conducted if cathodic protection is required, and ensure touch-up paint is applied in case of epoxy coated reinforcing bars and no cathodic protection is permitted on epoxy coated bars. We just assess concrete quantity in this case. How much is that? Let us say it's 4 meter, 12, 6, 4 for 10, 16 meters. 4 for 8 and say 3 and 3 6, 14 meters. We can say about 14 meters perimeter. So concrete is here, we say 40 thickness. Thickness I think is 40, right? Maybe it's not given. Well, let us say 40 centimeter thickness. It should be then how much? 14 into 40 is 0.56 into 1, 5.6 cubic meter in 1 meter. Or you can say 14 into 4.4, this is 5.6 into 0.4, 5.6 into 0.4, 2.24 cubic meter in 1 fill of 400 mm. 2.4 that one. That value is very important here. So we can say that, so many cubic meter it will take how many hours? There are 10 layers, so if one 5 points, if this cubic meter 0.56 into 4, 2.5 cubic meter approximately takes half an hour, and there will be 10 layers, so 10 hours more, it is 10 hours more. You have to consider that way. 10 hours more. It's big pole. It's time consuming pole. We can't cover that. So let's go to other one. Staircase works. Staircase works. Let us see how it works. Just trying to find if I can get some drawing of staircase, and let's see if I can find some drawings. It'll be okay, otherwise I'll come back immediately. Let me see some other, not this one. Let me see this one, if I can find something here. Let me see. Geometry. Geometry, no, not geometry. Something, I forget what it was. I think that one. Okay, let me see which drawing is that. Old drawings. Alright, old drawings here, and old drawings. Let me see how it works. Just give me some time. We have till that time. It's opening up. Let me see how it opens. Okay, if you can open, I'll find that. I'll do it. I like to see if something is there. I'm getting this drawing. Meanwhile, you can read this and stare in this drawing. I'm supposing it is and must be, but it's an AutoCAD, so don't worry about that. I'll make it. You can see I got it done. So let me see how can I do it. A plot is set up, plot payment, plot style, plot. I'm just going to plot it. And let us see if I can do it. I think it's better. Window. That window is here. I think I got it. So I'm lucky that I got it here. So you can see this staircase here. This is a staircase here. You can take savings of this also. Let me save it also in this staircase. Let me see staircase. Okay, now we got this staircase here. I can also see if something is better if we can find. I think I will not find anything else. So I close this file. Okay. Alright, gentlemen, what happened now? I have for you this section of staircase which I am going to talk about. This is beam, or you can say foundation, from where this basement portion here. This is ground floor, this is first floor, and this is second floor, and this is stair cover. This general construction of staircase. I have to understand that. It's very important point. General construction of staircase. So let me put some. So I'm going to discuss about this staircase, formwork of the staircase. Now what happens? You can see in this staircase, this is start here basement, and because this height is up to here, we have this landing here. This is different height, not like others. So you can say here we are starting from here, but here we are starting here, and this is waste slab. This is waste, and this is below floor, below slab. This one soffit, and these steps, equal steps. You can say here 125 mm is riser, 125 mm is riser, and accordingly treads. It goes up, we go to ground floor. Now what actually we have to give to our people to construct? That's the important point here. I close this lift now, it's not required. Okay, this stair, and I say in statement that consider in-depth coordination on drawings for relevant involved parties, involved activities. Actual details pertaining to follow-up settings should be charted. I will explain this one. Now first we understand this, what we want to say. What you have to give to your carpenter or your charge hand, whoever is for formwork or foreman, you have to give this information. You have to give this information, means this point Of course, when you have this point here, we got this point here, height is there, that can be given, that is here, this height, and this dimension is important. Of course, this dimension is available, this dimension, but important is because they cannot start here, they have to start from here. So this dimension, and this dimension, those not given here, but I would give all this dimension to that carpenter or foreman, so that they have a height here and they have this. Means every dimension is not shown in this, but in other triangle it is shown. Here point is for clarity, so I gave only waist dimensions. This dimension is known, this dimension is known, this dimension is known. So this dimension we give in a sketch form, so that they can fix successfully all this. Here also you see I tried to give this dimension, not shown in this time, but we try to give these dimensions here, this dimension. Similarly, we try to give all dimensions, like this dimension here, this dimension here, and landing dimension is known, but we have to give this beam, we know we have to give this dimension here, this beam they know, this they have to be given, we have to give them. It's 503 for example, they can join these points. Complete dimension must be given to them. For example, this dimension is there, this dimension is there, top dimension they know, that's in plan, and better you give also. So this dimension for work purpose, this dimension for work purpose here. Of course, then this dimension is known and this dimension is known. They are to be given all those dimensions on which form is to be done, not surfacing form. At that moment when they work on shutters, if this waist form profile is clear, that is main requirement. It's minimum, I'm telling you. If I complete, there's another triangle also, but I'm showing you this one only. For staircase, particularly for staircase, riser is 125 mm and trellis is 50 mm. I decided floor height based on this. I did not work out riser, but I worked out floor height based on this riser. There are 26 risers here in one floor. Yes. Whatever number of risers here, you can fix them and find floor height. Other framing is there. You can see these columns, main columns, beams, all framing is available there. And all these beams in foundations, no footing, and these are cross beams. Here in this not framing, cross beams, framing is here only this. And this span is approximately here, let's say from here to here. Here to here, sorry. Here to here is about 11 meter or more. This one. You have to keep in mind. So what it says in method, conduct, you can say, conduct in-depth coordination on drawings for relevant involved activities. Conduct in-depth coordination on drawings for relevant involved activities. Actual details pertaining following follow-up settings should be charted out clearly for communication to site. Because an error, when I say for here, it's because an error may mar site work in staircase form work. Setting of lowest beam can be carried out in one go easily, whether or not it is monolithic with grade slab. I'm talking of this beam, that is this beam here, which starts here, because there's no continuity here. This beam is terminating beam here. It can be done in grade slab. You have to decide that one, because only half of this load is coming here and upper loads are not coming onto this. So you can say what it says, setting of lowest beam can be carried out in one go easily, whether or not it is monolithic with grade slab. Monolithic with grade slab. Okay. Setting of lowest beam can be carried out in one go easily, whether or not it is monolithic with grade slab. Consideration of columns is a little tedious job, for a decision requires to reach about whether stage casting of columns or full casting allowing insertion of dowels. That's what I'm talking about, and it is here. Now in this portion you have to see that this landing is coming here, right? This landing is coming here, and this second flight is going to slab. If this waist and this landing are there, though it's not full landing, but let us say there is another one here, another step. So this portion here meets column. This is structural slab and this is structural column, and we have beams as well. Now common sense says that we have to cast this column up to here first. Otherwise this reinforcement, where it goes, you can't take it to columns by dowels, is impossible. So we have to cast this column up to here, and this column we have to take full. That is what is important. We have to decide that way. Here this is slab portion with column, and that this one, if we cast this column here, this is one stage, and another stage comes from here about here, where construction joints comes somewhere here, and if you have capacity you can take both, but that is generally not done. Practice is you have to make construction joint here, just to make construction joint here, and portion of this with slab be cast. That is main point. Now setting of first waist slab requires dimensions of waist slab. Setting of first waist slab requires dimensions of waist soffit. Now setting out of the dimensions, I told you these dimensions I'm talking of, these dimensions, these dimensions, these dimensions, all such dimensions they have to say, we have to give them. This we can give, no problem. Setting of first waist slab requires dimensions of waist soffit. Setting of landing beams slab requires dimensions of soffit and beam soffit, upstand or downstand, whatever it is. Generally here you see, you can say, generally I am telling you, it's not necessary. Landing here, in this case we generally can take upstand, not shown here but it's shown somewhere else. Upstand we can take here, and we can take upstand here also though not necessary downstand or upstand, both work, but landing, this is not actually, this is also landing, though it is floor. If you say here, there are options that whichever you want to take, you have to take depending on their structure. I'm just trying to indicate, the decision is yours. How it works on your slab, that point is important. This case which I am showing is an extraordinary case because of complication on bend with this plot is a little different. So I say setting of landing beams, slabs requires dimensions of soffit and beam soffit, upstand or downstand. A setting of mid-landing requires dimensions of soffit. Setting of second waist slab requires dimension of waist soffit and beams and slabs. Setting of floor portion landing requires slab dimensions in line with main slab. Setting of upper structural floor beams that constitute surrounding beams as part of framing. Setting of upper structural floor beams that constitute surrounding beams as part of framing. I mean to say, when we are here, when we are here, our structural slab and beams are here, but I'm talking of this slab, this beam. I'm not showing plan here, but if you see plan, this would come and go then this way and then go back. These three beams, two parallel to stay here, and this they are taking here at mid level or landing level. So I am talking about these beams. And setting of upper structural floor beams that constitute surrounding beams as part of framing. Ensure correctness of riser and tread dimensions being very significant. Ensure correctness of riser and tread dimensions being very significant. Ensure structural floor height to structural floor height match with riser size summation or number of risers multiplied by size of riser. So that shall be floor to floor height, rather than considering floor to floor height and finding vertical dimension of risers. In general, calculation and setting dimensions is a cumbersome process for staircase work on site. Being a design issue, it is better ways to fix sizes of risers and treads to work out floor height and staircase envelope dimensions. Working foreman or charge hand carpenter requires full details that either junior supervisors or surveyor on site may not rightly communicate. Check whether or not all required dimensions are indicated on drawing. In case of some important dimension missing, use soft copy for charting out required dimension. Okay, then it's not tedious job. It's not a tedious job by AutoCAD or software to work out such dimensions for site use. Calculating sizes using formula shall not be much supportive. It is significant to note that carpenters shall require relevant dimensions necessary for setting out formwork in 3-axis dimensions. Check whether or not supporting system scaffolding for stair waist is consistent with requirement. Is consistent. Check whether or not supporting system scaffolding for stair waist is consistent with requirement of design. It's easy to work upon if this system is supplied by proprietary manufacturers, or it requires to be designed on site using traditional methods. For explicit explanation, it is better if whole floor plan be worked out, indicating supporting system based on proprietary dimensions, couplog or others provide. It has been observed that many adjustments are made on site for such purposes. Check whether or not complete stairways can be poured in one go or in two stages. Check all reinforcing bars and have those placed in right locations. Check all reinforcing bars and have those placed in right locations. Check all electrical inserts that are in place. The important item, electrical inserts. Complicated, maybe not much, but some electrical points and soffit in both flights and their panels on waist edges. Check all risers are in right locations and well anchored using middle anchorage supporting system. Check whether or not trailing inserts, handrail inserts required at this stage or preferably not required as embedments. Check all forms are fixed properly and well secured. All forms are fixed properly and well secured. Inspections to be conducted for all items. Plan for pour whether or not first portion separately and second portion with suspended slab. Plan for pour whether or not first portion separately and second portion with suspended slab or planning pour all with slab as an option to be work decided. Planning pour all with slab as option to work decided. I repeat, plan for Plan for pour whether or not first portion separately or second portion with suspended slab, or plan pour all with slab as an option to be decided. And how you want to pour, you have to decide. It's your choice how it's feasible for you and how it's applicable depending on type of stair we have. It may be dog leg stair or some other where your shutting should not be trapped in. Reinforcing bars particular requirements, as we said before. Ensure reinforcing bars are clean and free from rust. Free from rust. Ensure sacrificial anode is fixed if so required, in which case non-epoxy coated bars shall be included. Ensure that electrical continuity check shall be conducted if cathodic protection is required. Ensure touch-up paint is applied. Ensure touch-up paint is applied in case of epoxy-coated reinforcing bars, and no cathodic protection is permitted on epoxy-coated bars. I have given this some statements today in furthering this quality requirement, and this shall be useful on sites if you are working in some, you can say, good construction industry, probably in this country as well, and also overseas in Gulf countries in particular, because standard of quality I think is much better if you take example of Iraq or Qatar, or you take examples in UAE. Generally in Qatar and UAE they have their own standards of specifications, and also in oil sector specifications of ADNOC and QP work there, which are much advanced. So we have to apply their applications, their specifications, and these specifications I am sharing with you generally come from that. We have to learn everything, and that's an important point. So I like to now leave today this time due to already time is more than 3 hours. I'll take up probably again next time if I find I have to think again, I have to work again on revision of these statements before sharing with you. And I think yesterday evening I did that, and today I am lucky that I got this Facebook supporting. The system worked well, and we should say that enough. Sometimes it's good time, sometimes it's not good, but quality has to continue. There is no way we can say no, but yes, quality has to work, and it is only because of engineers quality works. And if engineers are determined in that way only, if engineers are not determined, quality cannot work. That is very important point. If engineers are determined, quality would work, and if they are not determined, then we have to forget quality. That's main point. So I hope you enjoyed. Up to you. I have no say in that. And with this, I close this now.